Hi, how are you, student grade 12? Today, inshallah, we're starting the first chapter. The first chapter is electricity and current, chapter 18 and 19. Okay, we're going now for sharing screen with these notes. Okay, the first page, it's about units and geometry formula sheets and geometry symbols and how to calculate the area. Okay, and this formula and contains 4 chapter electricity. Okay, first, current of electricity. All matter is made up of tiny particles called atoms, each consisting of the positively charged nucleus with the negatively charged electrons moving around it. Charge is measured in units called coulomb. This charge on the electron is how much? Is minus 1.6 times 10 power minus 19 coulomb. Normally, atoms have equal number of positive and negative charge, so their overall charge is 0. For some atoms, it's relatively easy to remove an electron, leaving an atom with an balanced number of positive charge. This is called positive ion. Atoms in metals have one or more electrons, which are not held tightly to the nucleus. This is free or mobile electrons wander at random throughout the metal. But when a battery or source is connected across the end of the metal, the free electrons drift toward the positive terminal of the battery or sources, producing an electron current. The size of the electric current is given by the rate of flow of the charge and is measured in units called amperes with the symbol A. A current of 3 amperes means that the 3 coulombs passes a point in the circuit every seconds in 5 seconds. With a total charge of 15 coulombs will have what? Will have passed the point. Okay, the matter, it's divided for 3 things: conductors, insulator, and semiconductors. Examples of conductors is metals, insulators rubber or plastic, semiconductors silicon and germanium. The difference for how many electrons for high electron density and lower electron density and electron density. This is different. And this chart is talking about circuit symbols. We know the symbols and the name, symbol and names, between connecting lead to emitter and variable resistors to semiconductors and light emitting diode. Symbols. Electric charge. What is the electric charge? Electric charge is the property posed by the protons and the electrons. The charge carrier by the electrons and the proton within atoms are equal in size and opposite in sign. How much is 1.6 times 10 power minus 19 and opposite in size? It's positive protons and negative electrons. What is the electric current? Electric current is the rate or the flow of the electric charge carried by the charged particles such as electrons. Like this diagrams, we can see there are 2 directions. There are conventional currents. What is the conventional current? Conventional current, it's movement from positive terminal to negative terminal. Like what about electron directions? Opposite, from negative terminal to the positive terminal. Inside the metal wire, there are some negatively charged electrons which are free to move about. These electrons which are not tightly bonded to the metal's atoms are called free or conduction electrons. When a battery is connected to wires as shown above, the free electrons experience an electric force which causes them to drift between the metal's ions toward the positive terminal. See the electron drift, which contains the electric current. What is the electrons flow in the opposite direction to the conventional current? The electron flow in opposite direction to conventional current. How to calculate from this formula? Charge is equal current multiplied by time. What is charge unit? Coulomb. What is current units? Ampere. And what is the unit for times seconds? What is 1 coulomb? 1 coulomb is the quantity of the charge which flow past point in a circuit in a time of 1 second when a current is 1 ampere. 1 ampere is equal 1 coulomb second minus 1. From this triangle, we can calculate it, Q. What's Q? It's equal I multiplied by T. What is I? Q over T. What is T? Q over I. And this is the same thing for units. 1 coulomb is equal 1 ampere multiplied by 1 second. 1 ampere is 1 coulomb over 1 second. 1 second is equal 1 coulomb over 1 ampere. Okay. Then an equation for current. Any electrons moving through the wire. So we know that's where there is a repulsion, electrons moving in one direction. So from these directions, we can calculate first the drift equation for current. This is the equation of current. This is what its mean drift velocity. Current is equal NA VQ. I is equal NA VE. Q or E, it's depend about the charge. What is the charge? Is electron. We can write E. Charge is proton. Is small q. Okay, how to prove? First, we're going for the number of electrons. Number of electrons is equal number of density multiplied volume of wire. What is the volume? Volume is E multiplied area multiplied length. Area, yes, we can see here, there is area. Okay, and there is cross-sectional area, and there is the length for the wire. Once we calculate the length of the wire and the cross-sectional area, we can calculate the volume of wire. Volume of wire multiplied by the number of density, we can calculate the number of electrons. Then we can calculate the charge of electrons. How to calculate the charge of electrons? Charge of electrons equal number multiplied by electron charge. Multiplied by electron charge. What is the electron charge? Electron charge is the same thing. A volume, we know the number of electrons. It's number density multiplied by volume. So Na, this is the number. NaL, electron charge is E. So the charge of electrons equal number of electrons multiply the electron charge. Give a number of electrons. What is the number of electrons? NaL. Okay, NaL multiplied to what is the electron charge is E. So we can calculate again the current. Current is equal NaLe divided by T. Why? Because current is equal total charge divided by T. Total charge is given by NaLe divided by T. L divided by T, we can cancel and write what? Velocity. So we can write NaVe. NaVe. This is the equations. What is the variable? V directly proportional with N. Double the current, double speed. Half the area, double the speed. And we can see the relation between current and cross-sectional area, current and velocity, current and the charge. From this equation, we can find current, number, density per meter minus 3. A is cross-sectional area, and V is velocity. What is E? The charge, electron charge. This equation of current, equation of current I is equal NaV. Then notes N in for different metals. For example, copper is 8 times 10 power 28 meter minus 3. Okay, which is why it's such an excellent electric conductors. V is very small, typical less than 1 millimeter per second. The reasons for this is that as the free electrons moving along the wire, they have numerous random collisions with the vibration metal ions, which make their motions very hazard. So even through the actual velocity of the electrons between the collisions equally it's 10 power 6 meter per second. This is the drift velocity when the velocity is 10 minus 3 meter per second. Okay, how to calculate? This is the rocket example. Calculate the mean relative velocity of the electrons in the copper wire of a cross-sectional area. What is the cross-sectional area? 5 times 10 power minus 6. Carrying a current. What is the current? 1 ampere. The electron number density of copper is 8.5 times 10 power 28 meter minus 3. First, we wrote the formula. V is equal I over NA. E. Check the unit. Check the unit. The unit cross-sectional area meter square, current with ampere, and number density meter minus 3. So all the same, we applied the numbers in the formula. 1 over 8 times 10 power 28 multiplied 5 times 10 power minus 6 multiplied 1.6 times 10 power minus 19. So the answer is 1.47 times 10 power minus 5 meter per second. Or after rounding or changing the units, it's equal 0.015 millimeter per second. Okay, another example. Given that the electric current flowing through circuit 0.76 milliampere, calculate the electric charge which is passed each sections of the circuits over time of 60 seconds. Solution. How to calculate? First, we write the formula Q equal IT. What is the given? Current, milliampere, must be converted to ampere. How milliampere to ampere? Multiplied by 10 power minus 3. And 60 seconds is correct. Applied in the formula. This is I, 0.76 times 10 power minus 3 multiplied by 60. It's equal 4.56 times 10 power minus 2 coulomb. Example 2. Over a time of 8 seconds, the electric current flowing through a circuit component is reduced. Take care, it's reduced uniformly from 60 milliampere to 20 milliampere. Calculate the charge that's flowed during this time. How to calculate? Yes, look for diagrams. The y-axis ampere per milliampere current, and the x-axis is time by seconds. Take care that there is a reduce from 60 to 20. This is the triangle, and this is what? This is the square. This is the triangle, and this is the square, rectangle, triangle, and rectangle. Okay, area under the current, time graph. How to calculate the area under the current? Because this is the reduced, so we can write half. What is the base? What is the base is 8 multiplied by 60 plus 20, because starting from 60 and ending to 20, so not subtraction, will be add what? Plus. Then multiplied by 10 power minus 3. So the answer is equal 0.32 coulomb. 0.32 coulomb. Okay. Then we can see here this video. This video is talking about the electric currents. Okay. Let's see.
Suppose we take our circuit of a battery and a light bulb and we make it slightly more complicated by adding a switch. When the switch opens, the charged particles are prevented from passing through. Particles with the same charge repel one another, and they therefore spread out throughout the wire. The events shown here all happen at the same time, and this is the result. For the light bulb to turn on, the switch must close so as to create a complete path for the charged particles to flow around the loop. If we have several light bulbs, Each light bulb can have its own individual switch. Or we can have one switch which controls all the light bulbs. The number of charged particles that pass by each second is what we refer to as the current. The charged particles flow through the light bulb because the battery causes them to have a higher potential energy on one side of the light bulb than the other. This potential energy is what we refer to as voltage. If both sides of a light bulb are at the same voltage, then no current will pass through it. As the voltage across the light bulb increases, the amount of current through the light bulb also increases, and the light bulb produces more light. When a switch closes, it causes the two different parts of a circuit that it connects to be at the same potential energy. If both sides of a light bulb are at the same voltage, then no current will pass through it. Through a light bulb, then this means that both sides of the bulb are at the same voltage. A properly working battery ensures that the difference in voltage across it is always at a specific value. All points that are directly connected to each other through metal conductors and closed switches are at the same voltage. This means that if we have several light bulbs connected to a battery in parallel, the voltage across each light bulb is equal to the voltage that is produced by the battery. Since the voltage across the light bulb determines how much current passes through it, each of these light bulbs will have the same current pass through it as we had when we had just one light bulb connected to the battery. The total current drawn from the battery is the sum of all the currents drawn by each of the light bulbs. Now, let us consider a situation where we have several light bulbs connected in series. Since the total voltage across the group of light bulbs is at the specific value set by the battery, the drop in voltage across each light bulb is only a fraction of this. Since the current that passes through each light bulb depends on the voltage across it, this smaller voltage across each of the light bulbs means that a smaller current will flow through them. This means that the lights will not be as bright. Because the light bulbs are connected in series, this means that the current passing through each of them is the same. The amount of current entering always has to be equal to the amount of current exiting. This is what we refer to as Kirchhoff's current law. This is accompanied by another law called Kirchhoff's voltage law, which states that as we travel around the loop, the amount of voltage increases that we experience must be exactly equal to the amount of voltage drops that we experience.
Okay, Shabab, this is the everything about current for this lessons for today. Okay, then what is important? Take care about how to calculate the current or draft velocity. I is equal NAVE. Then what is the definition for Coulomb? The quantity of the charge which is flow passes the point in a circuit in a time. Okay, 1 Coulomb, the quantity of the charge which flow past the point in a circuit in a time. 1 second when the current is 1 ampere. Okay, this is 1 Coulomb. This electron flow is the opposite direction for the conventional current. What is the electric current? The rate of the flow of the electric charge carried by the charged particles such as the electrons. Okay, and that is all. Okay.